Okay, so the, I need to look at here. So we're looking at Roman numeral 2, and I'm going to mention all the things you need to know on just this. So when I say, yes, you need to know this, no, you don't need to know that, it doesn't apply to anything else you're studying here. We've already talked about the models and the sheep brain, what you have to know, with the stars, the 1 star, the 2 stars, etc. So what we're going to go through is just what you need to know for the practical, not the brain quiz, the practical, here with these human brains. So the dura mater is this very thick, hardy membrane that we see on this kind of detached, more or less. It's been removed from this brain. So this is the dura mater. It's the outermost layer of the meninges. And we also saw that on the sheep brain. The arachnoid mater is this thinner membrane underneath the dura mater. It kind of adheres rather tightly to the surface of the brain. So anything I'm describing or showing you, you can highlight or underline. That is fair game for the practical. Okay, so the dura mater's here, the thicker, it's very durable. That's where it gets its name, dura mater. And then the arachnoid mater is this thinner membrane that's kind of wrapped, it's right on the surface here of the brain. Okay? You can come a little closer if you can't see. If you're fine there, then you're fine there. Okay, next is the cerebrum. So this whole all the wrinkly part, I think you know, the wrinkly part is all the cerebrum, okay? And not only do you have to know the cerebrum, you have to know the lobes of the cerebrum, which is sooner or later, we'll see that on the sheet, so we'll just take care of them right now. So this entire thing is cerebrum, and this is the frontal lobe, near like the forehead, frontal lobe, and then occipital lobe is in the back, over by the cerebellum. Occipital lobe is over here. The temporal lobe is to the side by the ear. Temporal lobe. Temporal lobe. So those are the 3 easiest ones. The hardest one, and it's really not too hard, is the parietal lobe. It's just kind of in between all the other lobes, so students get confused, like where does it end, where does it begin? I'll point right to the middle, in my estimation, of the parietal lobe. It's like right here at the crown of the head. So this here is parietal, occipital, parietal. Occipital, parietal. This is occipital and parietal, and then frontal, temporal, parietal, occipital, frontal. Okay? So altogether it's cerebrum. Name this part of the brain. Cerebrum. Name this lobe of the brain. Occipital. So don't forget to answer the question being asked. Longitudinal fissure is the line, a fissure, that divides the left and the right hemisphere. Okay, so I've kind of got the probe in the longitudinal fissure. That's kind of an easy one for students. There's some dura mater. This is kind of clogged up. There's dura mater and blood vessels kind of in it, but you can see it. Okay? You can see it in the front here. That's the longitudinal fissure. Okay, cerebral cortex? No, not on this human brain. You don't have to know it. Gray matter? No, not on this brain. White matter? No, not on this brain. Cerebral lobes, we just went over, frontal, parietal, temporal, occipital. So those, again, you don't need to know them on here, but you still need to know them on the other stuff. So be careful just scratching things out too heavily. You still got to know them on other stuff. All I'm talking about is what you have to or don't have to know on the human brain here. Then after the central sulcus, no. Pre and post central gyri, no. Transverse fissure, yes. Transverse fissure is between the occipital lobe and the cerebellum. Okay, so right there is the transverse fissure. Transverse fissure. Transverse fissure. This is the back now. There's the cerebellum. It's between the occipital lobe and the cerebellum. That's the transverse fissure. Probably the next one's lateral fissure. Well, it's sometimes called lateral sulcus. It's not that deep of a fissure. I think it's best shown here on this half brain. It doesn't really matter. It's kind of an easy one. So lateral fissure is over by the temporal lobe. Separates the temporal from the frontal lobe. So I've got the probe in the lateral fissure. It's the lateral fissure. Separates frontal from temporal. So that's the lateral fissure. Some books call it a sulcus. A sulcus is a shallow groove, a fissure is a deep groove. And the middle ones are, it's kind of a judgment call. To me, this is still a fissure. It's deep enough to be a fissure. To some books, it's just called a sulcus. Either one's fine by me.
It separates
The temporal from the frontal, mainly. The lateral fissure. Corpus callosum is shown differently on both, but you can see it, I'm sorry, not on both, just on this one. I had two halves out here earlier. Corpus callosum, okay, so we're going to look at three things here. The corpus callosum is here. The membrane under it is septum pellucidum. The membrane has a hole in it, and I'll bring it up for everybody to see in a moment. So corpus callosum, then the septum pellucidum, and then this thicker thing under the septum pellucidum. Anybody know what that is? Fornix. Fornix. So corpus callosum, I'll put the pointer on it and circle around. Okay, corpus callosum is right here at the tip of the pointer. It kind of, you know, swings all around, but that's corpus callosum. Corpus callosum. Corpus callosum. Corpus callosum. Okay. Septum pellucidum with a hole in it, and in the hole is the lateral ventricle, which you'll have to know whenever we get to it on the blue sheet. But the membrane is septum pellucidum, and the inside of that hole, it's been ripped, is the lateral ventricle. So nice example of the septum pellucidum. Unfortunately, it's tearing. Okay, and then underneath that is the fornix. So this is not quite as thick as the corpus callosum.
I'm sorry.
Okay, don't kick me. Minus one. Okay, so here is the fornix. I'm trying to like show it. That's the fornix. This, it's a little hidden. It's a little shy from the septum pellucidum. But the fornix is this white strip, you know, kind of resembling the corpus callosum, but it's much smaller and inferior. Okay, so that's altogether we covered four things there: the corpus callosum, the septum pellucidum, the lateral ventricle, and the fornix. And I'll do this again, or actually if you have questions, if you kind of have a bad seat in the house, then you can, you know, I can point them out to you again after we're done here. The olfactory bulb and tract are under the frontal lobe. Not there. Okay. One is intact. It's not real prominent. The other one has been cut. So we're looking at the underside of the brain, everybody, inferior perspective. This is, for starters, you could call this the olfactory nerve. Technically, it's not. But the end is the olfactory bulb. Okay, so that knobby end is the olfactory bulb, and then this skinny part is the tract. So I'll just do this. Okay. Bulb and tract, bulb and tract. I'm pinching the bulb, and then the tract is the skinny part that goes to the brain. So this is the bulb, and it's kind of like the olfactory nerve. The bulb is at the end, and then the tract is the skinny part. The other one has been broken. It was here. And then on this one, it's been mutilated. So we don't see it there. But it's kind of an easy one. It's under the frontal lobe, because your frontal lobe is by your forehead, so where would your olfactory have to do with smell? Where would that be? Well, your nose is right here, so the best spot to put those things is right under the lobe. It's like right behind your eyes, right above your nose. That's where this stuff is. So it's under the brain, under the frontal lobe. Okay? Any questions on that? That's kind of a tricky one. It's not shown real well here, but I mean, it's definitely here. Okay? Again, if you can't quite see, I'll show you again. The optic nerve. There's two optic nerves. One goes to each eyeball. One of them has been tied off with black thread. And then there's another one, but it's not tied off. So the black thread, everybody see, we're of course under the brain again on the underside. And then this is the optic nerve. It's been cut. It's just a stump. Hey, right there's the olfactory. And there's the other one. Oh, it's been tied off and everything. Alrighty, so we have both olfactory bulbs and tracts. Okay, so we're good to go. Anyway, this was the optic nerve in black. So I guess the olfactory nerve is wrapped up in black, and then the optic nerve, one of them, is also tied up in black. Okay, so this is an optic nerve. It would go off to an eyeball, and there's the other one for the other eyeball. Ding, 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 ding. 2 eyeballs, 2 optic nerves. Then when they come together, that middle part is the optic chiasm. Okay, so the 2 optic nerves come together, and that middle part right there, there's the 2 optic nerves. When they come together, it's the optic chiasm. There's the 2 optic nerves, and when they come together, it's the optic chiasm, or chiasma. Okay, so this is the optic chiasm, or chiasma, where the 2 optic nerves come together. And quite frankly, as you'll need to know sometime in this course, is that half the nerves from your, kind of like the decussation of the pyramids, this crossing over, not all of the nerves from your right eye cross to the left, and vice versa, but half. So from your right eye, all of the neurons, half of them stay on the right side, the other half go to the left side. So in the optic chiasm, it's kind of like the decussation of pyramids with the crossing over thing, but only half of the fibers are crossing over. The other half stay. The right side stays on the right side, the left side stays on the left side, but half of them do cross over. That's what happens in the optic chiasma. It's the partial crossing over of the neurons within the optic nerves. This provides for stereoscopic vision, so you can judge distances better. Other animals do not have this. Animals that have the eyes on the side of their head, like most animals, they do not have optic chiasmas. They cannot judge distance very well. But they can see broader. If you have your eyes on the side of your head, you can see almost what's behind you. You can see this wicked field of view. Our field of view is more restricted, like in front of us, because our eyeballs are not to the side. But what we do benefit from here is that we have good judge distance. I'm not sure if you take to the theory of evolution, but that would state that human ancestors used to live in trees, and living in trees, it's very important to judge distance. Having the eyes on the side of your head, you'd end up missing the branch a lot and fall to the ground. So distance judgment was very important in our history, so our eyes are adapted to judging distances accurately. And that's what the optic chiasm provides for. If they didn't cross over, I know it sounds kind of funny, everything would appear more two-dimensional, no 3D movies without optic chiasmas. 3D movies are kind of trendy these days, although I still get a headache from those glasses. The cerebellum, it's kind of an easy one, and if you're lucky, I'll ask that on a practical. It's this big walnut-looking thing, 2 lobes actually, on the back, posterior, inferior aspect of the brain. Cerebellum. Cerebellum, 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 cerebellum. Okay? And then the vermis is part of the cerebellum. In the middle of the cerebellum, there's like a neck or a constricted region. Okay? The morning, some girl in the morning group called it like the butt crack. But I don't know, it's the vermis, this narrow region between the 2 lobes
I don't know
of the cerebellum. Okay, so I got the probe in the vermis. Okay, vermis. Okay. Thalamus. The thalamus is missing. I don't know how. I think it's missing.